So jitter. Phone company hates jitter. And what they decided to do is come up with what are we going to do this? They wanted to have a way to eliminate jitter. Back when they were circuit switched, there was never a jitter. Okay? Because you had that reserved link, remember? There was me, and I'm calling on the phone, blah, blah. I have a reserved link, even though, you know, the operator made a switch along the way. There's no congestion on my link. Right? Now the phone company wants to be a little more efficient. We talked about this, right? Circuit switched is inefficient for data. You guys remember that part? So if we're on a packet switch network, we want to give what we would call circuit switched quality of service. Okay? That's what we want to get, at least for voice and for video. So when grandma's calling, even though we might be packet switched, we want to be able to, you know, guarantee the quality of the call. Now this will be perfect before the break. So here we go. They came up with a protocol. We're just going to call it ATM. I'm not even going to tell you what it is. They wanted a protocol that would run voice and video over a packet switched network. Okay? ATM is the protocol. It has a fixed length frame. It is 53 octets long. Right? It's always 53 octets, and they call it a cell. I don't know why they call it a cell, but it's a frame and it's 53 octets long. This is kind of an alternative to Ethernet. Remember, Ethernet has that length field, and it says, you know, this is how much of it is, how long the data field is. In ATM, everything is 53 octets long. What that means is that a switch, we know what the clock speed of a switch is. Does that make sense? You guys know what the clock speed of your computer is, right? Well, you used to know. You can look it up, though, right? You know, I've got a 2.3 gigahertz processor. The switches are the same way. We'll just put X frames, we better call them cells. So we know a switch can process some number of cells per second. Are we good here? So what we can do is if we reserve, so now we go to a switch. So now if I'm talking to grandma, where's grandma? My grandma wears pants, so there. Oops, I don't have her phone. No, that looks terrible. Sorry. There's my phone. What, I don't know, whatever. So what we're going to do here is the phone company is going to say, Russell has just dialed grandma's number. As it reaches this switch, they're going to guarantee space for my call. Okay? I don't know if we call it space. Let's call it a time slot. Okay? So we guarantee a time slot on each switch. Look what I did to my thumb. Look at that. Just jab myself with the pen. Oh, it comes right off. Imagine that, washable marker, and it came right off. So when my kid was little, speaking of washable markers, he was left alone with Crayola washable markers right here, and proceeded to draw glasses. He drew glasses on himself, and he drew a goatee on himself in black marker, both in black. Now you can't see it, that's okay. And so it was very amusing, and we took a picture. And then he took a rag to wipe it off, and it didn't come off. So it's washable on like a surface, but not apparently on someone's face, although it just came off my hand. Maybe I got to it soon. If you get to it soon enough, it'll come off your finger, right? And so yeah, it probably is certain colors. The black totally stuck. And so he took him to school, and he has totally two black eyes, doesn't he? Even though he's undamaged in every way. All right, so where were we? Oh, time slot on each switch is guaranteed. So it's a time slot. They call this actually time division multiplexing. And so what happens is you would have like, you know, on a given link here or on the switch, you might have time A, B, C, and then A, B, C. And so, for example, when I made my call, maybe I get time B. That means that's always reserved for me. And since these cells are processed in exactly the same amount of time, my call can be pieced back together perfectly. There's never a difference in the delay. Okay? Yeah, it's like an assembly line. Yeah, that's a good way to put it. So we'll put that there. Like assembly line. So it's the same latency. It's always the same time slot, yeah. And so it's just little chunks away. And if they want to upgrade the capacity, so they want to be able to handle more phone calls, then they just buy a better, like a switch that can handle more frames per second, and a link that can handle more bits per second. And so even though this is data now broken up, it can be pieced together the same way as you have with a circuit. Since all those reservations are there, my voice is just as good as when it was up here. And it comes out just as nicely. Now, funny thing is, they're more and more hating it because it has 53 octets total and it's 48 bits of data or octets of data. So there's 5 octets of overhead for 48 octets of data, which is a lot. It's more than 10%. And the phone companies are like, no way, we don't like that at all. We want something like IP or Ethernet. Where is our Ethernet one? It has these huge long frames and huge data things. And so what they do, just to note, is more and more the phone companies are moving to, they still hate jitter, but what they do is they put you on a line with such high capacity that there's never any sort of bumping into other people. Because now, we talked about the dark fiber and everything, right? There's so much fiber out there and it has such high capacity that they can put these long frames on another network. We'll talk about IP stuff as we go. All right, so that was jitter and that was fun. And we talked about ATM and that was very good.